Okay, good afternoon, everyone. My name is George Demopoulos. I'm from Materials Engineering. And like Nigel said, with Audrey Moose from Chemistry and Neil Basu from Natural Resources Sciences at MAC, we are the three co-leads for this exciting materials, MSSI materials theme. So let us tell you what we try to do here. Materials are everywhere in everyday life. No reason to justify this. But we need to design materials that they will be sustainable for the future, because a lot of materials end up becoming waste with toxic, and they impose risks to life in all forms. So we want to develop new materials that they will meet sustainability criteria and to avoid all the legacy issues from the past. I come from a department, mining and materials engineering. In mining, it was mentioned about northern landscapes. There are a lot of legacy issues with toxic waste and so on. So we want to avoid all this. So to do that, as we develop new materials, we have to take into consideration risk. So we have to include assessment of all kinds to make sure that what we develop will be sustainable, because there's no point of working on something for publishing nice papers, and at the end this leads to another problem as you try to solve a problem to begin with. Okay, so we try to establish, like the previous colleagues described to you, a transdisciplinary, interdisciplinary research program to focus design, development, evaluation, and use of sustainable materials. Now, this is quite a challenge. There are so many materials. We need to start from somewhere. So we established three criteria: the material to be benign by design, to take into consideration, to assess risks, the 21st century protocols in terms of risks, and be stakeholder-driven, to be relevant, not to be just an esoteric type of exercise, as despite the fact that I come from engineering, also in engineering, we sometimes end up being very esoteric in our own little corner, doing research, publishing our paper, get the next grant and going. We have to change all this by focusing on materials in our case. So what kind of materials to work with? So we said, let's focus. There is a lot, when you look at the materials scientific literature, a lot of papers presently, a lot of research going on new energy materials, and many of those are nanomaterials, nanoparticles, and so on. What are the implications with the introduction of these materials to the market, to the society, to the industry? So we have to build a team. We have to assess the material in an interdisciplinary fashion. So we need expertise from different groups, from different disciplines, and to bring together. So building this functioning network. The three co-leads, we reach out to colleagues from different departments: science, engineering, law, management, medicine, and so on. And we have 12 co-PIs. You see names there. Some of our co-PIs are here today. And also, we extend this group into affiliates, people who have reached, we invite them to be involved with the particular activities. So we have a quite multidisciplinary origin group, and the pictures here are not to promote ourselves, just to show you the different backgrounds of our team, from engineering, chemistry, physics, management, law, pharmacology, natural resources sciences, environmental health, and so on. Yes. there is the affiliation of the different people. So it was Audrey who did this slide, so I missed that. So let's focus. So it was mentioned already, HQP. I mean, the future is the students. We are professors. We teach, we train people. I say that really the product of our activity is people, is these trained people. So we want to introduce a new type of HQP training environment that brings the interdisciplinary approach. So we started involving HQP in many of our activities, and we insist that the HQP have to be co-supervised by people not from one department or from one discipline, but from other disciplines too, to justify, to qualify as a project funded by MSSI. So I will stop here and ask Audrey to continue with some highlights from our work recently.
Thank you very much, George, for this great introduction of what we've been doing and the vision that we had for MSSI materials. So I'm going to talk a little bit about some of the things we've done in the last year. Obviously, when we started this, it was a bit daunting. We had a lot of questions about how we could put this together, and one of the big advice that we had was that we needed to do something that was different from anything that could be funded by one of the classic organizations that we receive funding from. So we had quite a lot of it was quite a challenge actually to think about things that way. And some of the ways that we did this was actually to launch this exercise of putting together this group of people and meeting regularly to figure out how we could work together. And it was really quite an amazing adventure to just learn from each other and learn to talk each other's language and start engaging into ideas that we could reliably do together. And what came out of this is actually something quite unique that I haven't seen in my career before, which is really completely novel ideas that were just emerging from having people talking different languages and working on different sciences together. And the way we did this was also to very early on include HQP. So HQP is highly qualified personnel. So it's anybody from undergraduate student to postdocs, so research assistants, and of course graduate students, and make sure that they would also be actors of ID generation as well as work. And I'm really proud today to actually let some of them talk to you today and explain what they're doing, because I think they're embodying the research and innovation of this structure much better than I could do myself. Some of the things that we do is we meet very regularly. The three of us co-PIs, we meet on a weekly basis, and then we have the meeting with the greater team on a monthly basis to twice a semester, depending. And then we're really having HQPs engaged a lot. So we had a very successful poster session where we had over 40 of our HQPs around there. So this is the photo that you see on the right-hand side. And we also had a workshop with students in August. It was really successful, where students started to have ideas sparking all over the room. So this is really exciting, and this is what makes this adventure so unique, I think. And also, exactly a week ago, exactly a month ago, sorry, day for day, we had a really successful CESTO Society event here with over 100 people attending, where we could showcase some of the development of our program. So what we're doing at the moment is really also developing an architecture so that the research we develop is really going through the design principles that George mentioned, and we're putting together this idea of checklist, which is something that we'll have as a guideline as we do research to remind ourselves of what our goals are. And the one thing that is really important to us is the assessment component. So how can we measure that the materials that we make will be better? There's a lot of the research that you're going to hear about today that have thought about this design of assessment. So we're trying to make this a bit more formally. And the interdisciplinary aspect is also very important. And hopefully, with the people talking to you, now you're gonna see this. So we have 2 case studies that we work on more specifically. It doesn't mean that sustainable materials are only developed in this area, but we just had to start somewhere. So with the people around the table, we focused on photovoltaics material. and Q dots that can be used for applications in electronics, essentially. So our goal is really changing the way we conduct research and also, of course, providing new materials for the future that will be more sustainable. And with this, I'm going to leave the floor to students. So we have 4 students together. We thought we would have 3, but a 4th came, and it's going to be really fantastic to hear him today, too. Our first student is Sylvie Danet. She's an MSc student. She's co-supervised with 3 people, so this is, again, a typical example at MSSI Materials. Neil Bessou, Sadie George, and myself. So, Sylvie, I'll let you talk about your research.
Quantum dots are now found in LCD screen TVs to improve the quality of the image and of our smartphones and also our laptops. If you step into a board meeting, such as this one on the screen, chances are you will find quantum dots in these screens. Once these screens are no longer working, they are deemed waste. They can be recycled, and unfortunately, some of them can end up in the environment. Quantum dot has at its core heavy metals. One that I'm looking into is cadmium, and cadmium is known to be persistent in the environment and bioaccumulate in human bodies, and which affect the liver. My name is Sylvie Danet, and I work under the supervision of Dr. Neil Bessou in the Natural Resources Department, and collaborating with the Chemistry Department. I look into assessing the potential toxicity of these quantum dots with cadmium at their core. I use the in vivo approach, which testing on cells of zebrafish and looking at cell uptake, enzyme activity, and gene expression. My research has the potential to give us a better understanding of these new technologies and be proactive in driving better recycling. Thank you.
So our next HQP is Rana Yekani from the Department of Materials Engineering, and she works in co-supervision between George Demopoulos, Peter Gruder, and Dima Perepishka. So, Rana.
Hi, I'm Rana. I'm George Demopoulos' PhD student, and I work on perovskite solar cells. What is particularly interesting to me is the issue of hysteresis that undermines both the performance and stability of these cells. And that's why for the past few months, me and my amazing collaborators, Athena from the chemistry department and Amor from the physics department, have been involved with researching the interfaces in these materials, how different interfaces, different combination of materials, and different processing routes can actually affect the issue of hysteresis and subsequently the optoelectronic properties. We are using different techniques, impedance spectroscopy, time resolved measurements, KPFM, AFM, and so on. So if you have any questions later about how these cells work or what characterization techniques we're using, feel free to ask me. Thank you.
So we have another student, Aude Béchou from chemistry, who is a PhD candidate working under the co-supervision of myself and Professor Subes Escocho. So, Aude.
Thank you, Audrey. So this project is very similar to the one that Sylvie just presented. I'll walk you through it step by step, though. So we take TVs and use an emerging technology in them, which is in the form of a plastic film, which contains these cadmium-based quantum dots, which gives TVs a higher range of color, but also makes them more energy efficient. Sounds great on the surface, we'd say. But we're looking at trying to make these materials especially relevant for the degradation and toxicity tests that will ensure whether or not we have any kind of risk based on these materials. To do that, I'm taking a look at environmentally relevant waters and combining them with these weathered TV films in order to find out really what form of cadmium we have and what other risks we could have in assessing these materials later on. Thank you so much, and I look forward to talking to you.
Thank you so much, Aude. And I don't have visual support for the last person because we thought, because he's very busy, and we're very lucky to have him with us today, we thought he wouldn't be able to make it, but this is Guillaume Pain, who's a postdoctoral fellow working under the supervision of Steve Maguire and Neil Basu, and he's going to talk more on some policy aspects. And yeah, thank you so much.
Thank you, Audrey. So I'm here to answer the question that you are all asking yourselves. What could management possibly have to do with the MSSI initiative? And so my name is Guillaume Pain. I'm a postdoctoral researcher with Professor Maguire at the Desautels Faculty of Management. I'm also working with Professor Basu, who's a co-PI in the MSSI initiative. And so Professor Basu is trying to develop a genomics-based plate to assess the risk of chemicals for the environment, 3 species of animals. And this technology has been around for some time, but it's not very well used, especially in regulatory agencies. And so what management researchers or social scientists are doing within the project is trying to identify the drivers and obstacles to the adoption of these new technologies, and also trying to determine whether these new technologies have a disruptive potential to change the way risk assessment is conducted at organizations such as Health Canada or Environment Canada. Thank you.
Thank you very much, Guillaume. So we're very happy, we're very pleased to have presented our development for materials MSSI. Thank you very much for your attention.